In the last session, we have seen about components for final velocity, acceleration, initial. Now we will have a simple example. A jet plane with a speed of 100 meters per second and slows down at a rate of, which is the acceleration, 5 meters per second over second, which is 5 meters per second square, as it comes to rest. So the first question is find the time interval, and the second one is the total distance. Okay, now let's solve this question based on the above example. To get before the total distance, we know that the acceleration is equal to the final velocity minus the initial velocity divided by t. So first we need to find time, therefore t is equal to the final velocity minus the initial velocity divided by the acceleration. We know the final velocity, we know the initial velocity. So it comes to rest means the final velocity is 0. So the initial is already given, which is 100 meters per second. The acceleration is 5. So it's actually deceleration. So t is equal to final velocity 0 and v initial is 100 meters per second. And divided by this is minus 5 meters per second, because as you can see here in the question, it says that a jet plane with a speed of 100 meters per second and slows down at a rate of 5 meters per second. This is the deceleration. It slows down within 1 second, it decreases by 5 meters per second, which means, for example, it starts from 100 meters per second. After 1 second, it becomes 95 meters per second. After 2 seconds, it becomes 90 meters per second. After 3 seconds, it becomes 85 meters per second. So this is deceleration. Therefore, it comes to rest means the final velocity is 0. Now let's come to here. So 100 divided by 5, which is equal to 20 seconds. This is the time that we have. So having this in mind, now let's proceed to the next step. We know that s is equal to the initial velocity multiplied by time plus half a t square. So based on this equation, we have s final, s initial, so we consider only s final. So s is equal to the initial velocity, which is 100 meters per second, and the time interval, the total time interval is already found, which is equal to 20 seconds, and plus half the acceleration is minus 5 meters per second square. T is 20 seconds square. So this will be equal to 100 multiplied 20, which is equal to 2000 meters, and this is minus and become minus, and this is 20 square is 400. So second square, meter per second square multiplied by, this is 400 divided by 2, it becomes 200. Second cancelled by second, and here we have 2000 meter minus 5 times this, which is 1000 meter. So 2000 minus 1000, and finally we get 1000 meter. Okay, the next topic is all about free fall. This one is 2.1.3, which is free fall motion. Free fall motion. So this free fall motion is the motion of an object near the surface of Earth under the only control of the force of gravity. Under the only control of the force of gravity. We don't consider any other force. It's motion. So free fall motion is the motion of an object. The next one is 2.13, which is free fall motion, which is the motion of an object near the surface of Earth, under the only control of the force of gravity is called free fall motion. So in free fall motion, acceleration, we have to consider the acceleration. It varies with the acceleration due to gravity varies with the first one that we need to consider is the latitude. It varies with the latitude. And the other one, next to the latitude, we have to consider also longitude, and then longitude. So with the variation of latitude, we have a change in acceleration due to gravity. With the variation of longitude, there is also a change in acceleration due to gravity. The other one that we need to consider is the altitude. So due to the variation of altitude, there is also a change in the acceleration. Okay, so having this in mind, we have to see that consider such a building like this one. Consider this is a building, just a schematic diagram that we have. So from the top of this building, if the first person, consider a person standing on the building, if he releases this object downward, consider the initial velocity in free fall is equal to 0. So it released, or the ball starts from rest, so the initial velocity will be 0. So when after the ball released, when you get the ball somewhere around this point, so the force that is applied on the ball is only the force of gravity. The force that's applied on the ball is only the force of gravity. So this is just a free fall motion. So here we have different types of questions. The first question is just to find h value, the height of the building. We may record the time. For example, the time it takes for this ball from the top of the building to the ground is, let's say, t is equal to 2 seconds. And if you are asked to find the height, h value, so h is equal to you can use a different formula. First one is just v initial multiplied by t plus half gt square is possible. So the initial is already 0. So h is equal to half. Then you have to consider the acceleration due to gravity times t square. The time is 2 seconds, so h will be equal to, the height of the building is equal to half multiplied by 9.8 meter per second square multiplied by t square, which is 2 square, which is 4. So 4 by 2 it becomes 2, then h will be equal to 9.8 meter per second square multiplied by, here we have 2 second square cancelled by second square. So 2 times this, it becomes the height of the building will be 2 times 6, 19.6 meter is the height of the building. 19.6 meter is the height of the building. This is one way of finding the height of the building. You can use also the other formula, which is h is equal to v final square minus v initial square over 2 times the acceleration due to gravity in free fall motion. Okay, there are so many questions to be asked based on this one. Now again, let's consider again this building. This is the building that we have. Okay. As I told you, this is just a schematic diagram for the building. Again, here is a person and the ball is released from rest. Or if maybe thrown upward, and goes to downward. When it's released, you may be asked the speed of this ball or the velocity of this ball when it arrives half of such a building. Let's say the building is, h of the building is, ball is going downward, and let's say h of the building, which is equal to 100 meter. Let's say the building h is equal to 100 meter. So when the ball is downward. So you may ask the velocity of this ball at 50 meters. So h is equal to, let's say, 50 meter, and the v initial is already known, which is 0. Therefore, let's find the final velocity. But before that, it will be more advisable to get the time when the time interval when the ball travels half of such a building. So let's use the other formula now to make it very simple. Let's take acceleration due to gravity is 10 meters per second square. Let's take for this. So h is equal to half vt square. So 2 times h over the acceleration due to gravity under square root is equal to t. 2 times h divided by the acceleration due to gravity. This is t square. So under square root is equal to the time. So under square root of 2 times the h value is 50 meter divided by 10. 0 cancelled by 0. This is under square root of 10 is the time. Time is square root of 10. Therefore, the final velocity, we know that h is equal to v final square minus v initial square over 2 times the acceleration due to gravity. The acceleration due to gravity. So 2 times 10 times h, which is equal to 50, which is equal to v final square. V initial is already 0. Therefore, this is 10, which is 1000, square root of 1000, which is equal to the value of v final. Square root of 1000, which is 10 square root of 10. 10 square root of 10 is meter per second, which is equal to the value of v final. Okay, so it's possible to use final, and we have got also the time interval. So this is the other way of finding the v final. So there is also another way of getting this final is, we know that the acceleration is equal to v final. You know, if we use the other one, we know that acceleration is equal to v final minus v initial over the time interval. So v initial is already 0. We need to find a times t is equal to v final. The acceleration is 10 meters per second square. This is square root of 10. Time is square root of 10 on this one. T is square root of 10. So multiply with square root of 10, which is v final. So 10 square root of 10 meter per second is equal to v final, which is the other way of finding the v final. 10 square root of 10, which is similar to this one. So you can use both formulas possible.